Welcome to a lesson with Dr. Powell. Let's take a look at limits and continuity of functions with more than one variable input. But first, let's kind of look at a picture with just one variable input. Okay, so suppose you have a continuous function. If we take a little bit above and below in the output of the function, in the y values, and we look at this and we look at the sector of the graph, kind of that is representative of those y values. So it's kind of like between two dotted lines. I mean, this is a lot like going epsilon up and down from a particular center y value on a continuous graph. Then kind of what we can expect then is that the shadow, so actually, the graph could go like this. The shadow that's cast on the x-axis from what's in the sector, you could call the pre-image of what you see in the sector, if you think about what's in the sector as being the image. So what I've just notated here, so maybe I'll put an open, because this is an open interval since that's a dotted line, kind of. So we're only looking at, so we're not including the ends. So these are like open intervals. So these open intervals are like the pre-image of this open interval in the among the y values. So you take an open interval of y values and it casts what we call a pre-image. Why are we calling it pre-image? Because the function itself is an image and what comes before it is what's in the domain. So let's call it a pre-image, kind of going down here. So the pre-image down here, notice that if you take this point and you cast it down straight down here to its x value lives in a whole open interval contained in that pre-image. This is essentially the idea between, or this is one of the ways of thinking about epsilons and deltas for continuity or limits. But I didn't even use a delta or really an epsilon, say. All I did was say take an open interval around this point on the y values and cast it down here. And if we again get if it contains, there's lots of open intervals, but if it contains an open interval that contains this x value, then we say this function is continuous at that point. And, or if this was an open circle, and that's an open circle right here, then we say that, and we have this occurring, then we say the limit of the function is that particular y value. So that's kind of a rough sense. So how would this apply to more dimensions? All right. Well, let's suppose that we have, okay, our input is like the xy plane. Okay. So with an x-axis and a y-axis, and we have a z-axis going up here, and then maybe we have a surface, a continuous surface of some kind, kind of floating up there. All right. So some kind of continuous surface kind of over the plane with different z values outputs. Well, if we were to like draw a dotted line through a particular point here, and then it kind of extends down here and goes to a point in the xy plane. If we were to take an open interval up and down, kind of centered at this point right here, then what we should expect is the pre-image that's cast. Well, what does the sector looks like? Basically, what we do is we have to like think of a plane here intersecting another plane intersecting down here, and kind of cutting it out from a height just a little above here and a height a little below. And the image that's cast needs to contain an open circle around that point. And if it does, then we say that the surface is continuous, or maybe that as your x and y values head toward this point, then your z values head toward the respective point here, if that's always true. So if you have an open containing an open around, we say that it's continuous, and then we have this limit idea. Um, so um, that's a nice way of thinking about it in terms of getting continuity and limits. Now let's think about that limit idea for a minute. So among xy values, what if we had like something like the limit as xy approaches 1, 1 of maybe something like x squared plus 3y squared. So this means that as our xy values get closer to 1, 1, that means the z values, which is this, should get close to something. Well, for a continuous function, it works the same way as it would for a regular function. You simply just plug in. So I can plug in 1, 1 here, and we would end up getting 4 for that limit. Not too bad. Okay, that's fine. So this is a little description. In the next video, we'll give another example of computing limits with using x's and y's. Thanks for watching.